In this part of the lecture, we're going to learn about the dimensional analysis, which is converting certain units from one to another. So before doing that, let's understand why it is actually necessary, right? So you know that science has many branches. We have physicists, we have chemists, biologists, and other branches that go from these central sciences. So, and in addition to that, there is also research groups all over around the world. So whenever people are working on research, these new discoveries, new experiments, and etc., there should be a language of communication. So unifying everything that is gained, whether that's going to be through publication or a conference or anything, there should be a certain way that people will be able to talk the same language, meaning largely having the same units, talking about conditions that are used for experiments and etc. Right? So in general, when we're doing a science, so the main thing here is to gain and organize a knowledge, right? So maybe you discover something and then you discover how you actually organize it, how you relate it to something else. So all of these, in order to keep this organized, we classify all of these processes, what's called a scientific method. So in the scientific method, you have the observation. So, and as a simple example, for example, observation, there is a cancer growing in these kind of species, like these cells are prone to getting cancer, etc. That's an observation. And then going into the more details, right? So you can get quantitative observation. It's going to be the measurement. For example, how many percent of the cell get a cancer in these specific conditions? Is it from the food or is it from something else? That's the observation. Or just in any like looking in any example. After that, there is the hypothesis. The hypothesis is just a possible explanation. Why do you think, for example, mixing these two chemicals causes an explosion? Right, so maybe causing the explosion, that can be another example of the observation. So you have the observation, you know that, let's say, mix these two chemicals together, there's an explosion, and now you need to explain that. To explain that, you're proposing a hypothesis. So in your opinion, why is it like that? Right, so you propose an explanation, and after that, you need to support your point of view. To support your explanation, you're starting to do experiment. And this is what the research is. You do an experiment to explain, to support your hypothesis. Why do you think this happens? Or maybe you know why it happens, but you're trying to work towards something. You're doing something to prevent it. Or if it's something good, then you're trying to enhance it, to support it. That's your research. You're doing an experiment, and eventually, if everything is successful, maybe you get a patent, or maybe it's something very important, in classical education. It goes into the textbooks and etc. So these are the three main phrases of the phases of doing the science, right? So you have an observation, you try to explain it, you try to prove your point of view by doing the experiment, and then after that you have the results. And the results, and even before the results, the experimental results needs to be shared. And why we need to have certain ways of communicating, right? So there is different kinds of units. There is international system of the units, there is a metric system, there is the custom systems in the United States or maybe some other countries. And so we need to have a unified ways of combining all of that. So for this, largely what's used is called the SI units. That's from French, so Système International. That's going to involve these units. So we have the mass, length, time, temperature, electric current, and amount of the substance. The SI unit of the mass is the kilogram. We have meter for the length, second for the time, Kelvin for the temperature. So it's neither Celsius, not Fahrenheit, it's Kelvin. Electric current is the ampere. It's not something that we'll use in chemistry, but what we will use a lot for sure is going to be the mole. So that's the quantity, the amount of the substance. And in chemistry, here's a definition of the mass, so amount of the matter that we're talking about. We have also for the volume. And what's important is for anything, that any quantity, you need to always have a number and you need to have the unit, right? So for example, in the length, you can have a unit in centimeters, inches, feet, yards, miles, and etc. So the simplest instrument for measuring the length would be the ruler. And let's say here it says it is a conversion. So we have 1 meter is equal to 3.281 feet. Now the conversion factor is this relation, right? So 1 feet is that many inches, 1 yard is 3 feet, 1 mile is that many feet, 1 inch is 2.54 centimeters, and etc. So these are the conversion factors. And it will be very beneficial if you learn all of these and you keep them in mind. And especially for this part, mainly, this is something that you're used to, you have been using for a long time, so it's something that you know, but try to also get an idea of the metric system, right? So what's the kilometer, meter, centimeter, and etc. So these are all given here. We will now also, these are some other prefixes too, the deci, centi, milli, and etc. Please go over this. Now let's talk about something that's called dimensional analysis. For example, let's say I have 2.89 inches, and I need to convert this to centimeters. So in order to do this, what I need to know is the conversion factor. And for that, we know that 1 inch is equal to 2.54 centimeters. Now here's the thing, right? So you can look at it and say that I know how to do it. I'm just going to multiply these two numbers together. Yes, it is correct when you have simple numbers, but when it gets more complicated, you have larger numbers, or especially if you have a conversion that's going to take not one step, but maybe 2 or 5, then it is when the dimensional analysis becomes very useful. So let's see how that works. In order to do any conversion, you need to use this, and from the conversion factors, you're going to derive 2 unit factors. One is divide this by that. So what I'm doing is I'm dividing 1 inch over 2.54 centimeters, or I'm going to divide the 2.54 centimeters by 1 inch. So what's the meaning of this? Now, because 1 inch is equal to 2.54 centimeters, then if I divide these or these together, this actually is going to be equal to 1. This is equal to 1. And that's why we're saying that this is the unit factor. It's a unit factor. And if I have any number and I multiply that number by this, I'm not changing anything. I'm not changing the absolute quantity, the length or whatever it is, because this is equal to 1. I'm only changing its unit. And this is what you do. So because you go from inch to centimeters, so first write down what you have. You have 2.89 inch. Then you multiply by one of these unit factors. And you need to choose the one that allows you to cancel the inches and switch to centimeters. That's why out of these two is going to be better, this one, because if I put 1 inch here, I will be able to cancel the inches, and I have 2.54 centimeters on the top. So once you do this, you now need to only do the math and keep the unit. So you need to multiply. I have 2.89 times 2.54, and that is equal to 7.3406. And if we be accurate with the significant figures, so in both I have 3 significant figures, then I can keep only these ones. So I can say that this is equal to 7.34 centimeters, because I have already gotten rid of the inches. Now, for example, let's say you are asked to find, you have 16.78 centimeters, and you need to find how many inches it is. Again, you're going to use the same unit factors, right? So it is still related to centimeters and inches. So go ahead and put this 16.78 centimeters times, and because this is centimeters, just put the centimeters here right away so you know that you're going to cancel this. Now out of these two, pick the one that allows you to do that. So you'll have 2.54 centimeters, and then on the top I'll have 1 inch. So in this case I need to divide 16.78 by 2.54. So let's do that. I have 16.78 divided by 2.54, which is equal to 6.60629, and etc. There's some more numbers. So let's now go based off the significant figures. And here, this is something important that you need to remember. These that we have here represents infinite number of significant figures. What does that mean? It means that 1 inch is equal to 2.54000, as many zeros as necessary, as accurate as necessary, that many centimeters. So you never restrict your answer based on the conversion factor. It's always going to be based on this, right? So in this case, I have 4 significant figures. Again, it's not 3 because this can have more zeros, as many as needed. So 4 significant figures, it means I'm gonna. Now let's go here. This is the example. So we have a foot equal to 12 inches, and this gives us 2 unit factors. And looking at the question, it says the ball is 6.8 feet across, right? So it goes 6.8 feet across. So how many inches does this represent? You're going to convert this 6.8 feet to inches. 6.8 feet times, you can just go ahead and put feet here because you're going to cancel these. So here I have 1, that's 1 foot, and it's going to be the 12 inch. So just multiply these two numbers. Next slide. Right, so multiply, and that gives us 81.6 inches. Okay, so if you come into a situation that you don't know the conversion factor, you can look up in the table and try to find a way around it, because maybe you will need 2 steps or 3 steps, right? So let's say here it says 7.82 feet is equal to how many inches? So the conversion factor here is, we know that 1 foot is 12 inches. So this is just simply 1-step conversion. Feet here, we cancel and we get the inches. And now let's look here, the distance from the Earth to the Sun. So we have 93 million miles, so we need to convert this to yards. So we're going from miles to yards. And this is a good example to show that there might be more than one way to do it. Maybe somebody goes from miles to inches, then to feet, then to yard. Maybe you go from miles to kilometers to meters to inches, then to yards. It's really going to depend what data you have. So this is the answer you can check. And now let's look here. This is also a good example because it represents how dimensional analysis is used when you have more than one step to do your conversions, right? So here's the route how it goes here. So it went from miles to feet to yard. This is what has been used in this problem. So what you do, let's do this step by step so we can see. So I'm going to start from the beginning. So I have 93 million miles times, put the miles on the bottom so you can cancel. Look up from the table, you can see that 1 mile is 5,280 feet. Now, as it stands, the miles are cancelled, and as it stands, this operation gives you your answer in the feet. And you can go ahead and write that down, whatever that number is already, and then do one more step. But you can also keep going. You can now continue and one second. So this, now your aim is to get rid of the feet. So put here, and you can look up and you can see that 3 feet is equal to 1 yard. So what this does now is it gets rid of the feet. So if you do all this math now, so you multiply this and then divide by 3. So obviously this is 1 times 1 divided by 3, but it doesn't change the number. So multiply these two divided by 3. All the units are gone except now conversions, because it makes it easier. Let's now do this together. So kilometer to centimeter. So let me tell you the units. So first of all, make a plan. Make a plan what you want to do. So you can say that you want to go from kilometers to meters to centimeters. That's one way, and that's the easiest in this case. Let's write down a kilometer is 1,000 meters. A meter, on the other hand, is 100 centimeters. So this will be the conversions. Now let's put this together. So I'm starting from 4.53 times 10 to the negative fifth. That's kilometers times whatever I use. I'm gonna need to cancel the kilometers, so just put kilometer on the bottom, and that's what I have. I have that 1 kilometer, this is the number, is equal to 1,000 meters times, now it stands at meters, so I'm gonna put a meter here so that I can cancel, right? Now I have a meter is equal to 100 centimeters. So I have this number times 1,000 times 100. So basically it's this number times 10 to the fifth, because 1,000 times 100, that's 100,000, and that's equal to 10 to the fifth power. So I have 4.53 times 10 to the fifth, and it's simply just going to cancel these. So the answer here should be centimeters. Let's now see what unit for the mass. So first of all, remember that there's a difference between the mass. The mass is absolute, is the quantity of the matter. It's not going to change, but the weight does depend actually on the gravity. Depending on the strength of the gravity, and weight can be different. The weight on the planet or on the Mars or on the moon can be different, but the mass actually stays the same. These are the main units for the gram. So first we have here the English system, so we usually refer to it with the pound, but in the metric system it is going to be the gram. And gram is the most common unit that is used in the labs because that's traditionally, historically, what turned out to be the most convenient amount of the matter of doing an experiment in the labs. Now, by definition, the gram is the amount of the water that is 1 cubic centimeters, which is, remember, 1 cubic centimeter is the same as 1 milliliter. So at 4 degrees Celsius, 1 cubic centimeter of the water has a gram of a mass. So that's by definition the gram. Some conversion factors that you need to know. So pounds relating to the ounce, pounds to the tons, grams, kilograms, and etc. Whenever you have a problem, you will need to choose from this or any other table, from any other source of how you're going to connect and relate and do your conversion. For example, we have two problems here, right? So let's say it says convert 164 pounds to kilograms. And there is another problem that is asking you to convert 1 ounce to grams. So pause the video, try to solve this. Use what we just went over on the previous slide, the conversion factors, and see if you find a way to link these units together, and check after that. So here the answer is 74.4 kilograms and 28.35 grams. And the way that you could link this, for example, the first one going from pounds to kilograms, because there's no correlation, direct correlation for this one, you could go from pounds to grams, and then you could convert the grams to kilograms. So remember, a kilogram is 1,000 grams, and a pound is about 453 grams, if I remember correctly. And so the way you would do it, you'd start from here, so 164 pounds times. Go ahead and put a pound on the bottom first, because you need to be able to cancel these units. And then you write down this, so you know that 1 pound is 453 grams approximately. And as it stands, I'm canceling the pounds, and whatever I get, if I do the math, my answer will be in the grams. And you could do that. You can multiply these two numbers, get an answer, whatever it gives you. You get that kilograms, and then you do one more step, converting the kilograms to grams. But the beauty of the dimensional analysis is that you don't have to do it actually. You can keep going and do as many steps as necessary to do your conversion, right? So I can continue and say that now I want to continue the grams to kilograms. So I put grams on the bottom, and I put that 1,000 grams is 1 kilogram. So in this way now I'm able to cancel the grams, and whatever I get on the end doing the math, the unit is going to be in the kilograms. So at this point you just need to do the math. So multiply these two together, and then you divide by 1,000. So everything on the top you multiply, everything on the bottom you divide, and that should give you 74.4 kilograms. So 453.6, okay. And so for the next one, connecting the going from the ounce to grams. So first you could connect the ounce to pounds. At this point you'll cancel the ounce, your answer will be in the pounds, and then the pounds now is going to convert it to the grams based on these conversion factors. And now let's talk a little bit about the volume. So the volume is going to be a bit trickier to calculate the volume in some cases, because it has two types of units. It has the ones that are simple volume units, let's say liter, a milliliter, I don't know, a gallon, a barrel, whatever. But we also have the ones that are in cubes. You have cubic centimeters, you can have cubic inches, cubic feet, and etc. So the centimeter, inch, and a feet, these are the length units. And if we cube them, then it becomes a volume unit. But sometimes the problem is to switch between, for example, go from liters to cubic centimeters or cubic inches and etc. So that can sometimes be a bit trickier, but we will do an example of that, see how that works. So in the metric system, we're using the liter for the volume, and this is just representing here the cubes, what we have talked about. So cubic centimeter, in this case, you'll have a centimeter on each side. You can have an inch on each side. So cube all of that, multiply it 3 times. That's going to give you the volume. And a liter is going to be cubic decimeter. So decimeter is 10 centimeter, right? So 10 centimeter, so to have an idea, 10 centimeters will be about 4 inches. So if you take something, a cube that is going 4 inches on each side, and a cube of that is going to be 1 liter. Now some conversion units, so quarts, pints, gallons, liters, decimeters cube, centimeters cube, and etc. So it'd be very helpful if you could remember all of these. But for you, the main points here is try to focus on the metric units to have an understanding what the liter is, the milliliter, cubic centimeter, and etc. Now, let's do one problem. So here it is asking to go from liters to pints. And what you need to do is go to the previous slide and find a correlation between the liters and the pints. See how you can correlate, right? So take a few minutes and try to do this conversion. All right, so it is the answer, 153 pints. And the link was to go from liters to quarts to pint. And so for each there is a conversion unit. A liter is that many quarts, 2 pints is a quart, and that's how you correlate them. You start from the liter, put the liter on the bottom to make sure you can cancel. The quart is here on the top, then the quarts on the bottom, so you can cancel the quarts now, and whatever you get at the end is going to be pint. Again, as far as the math, you multiply everything that is on the top and divide by the numbers that are on the bottom. In this case, you have ones here, so this is not going to affect the numerical value. And now let's put it here. So here's the plan. We're gonna go from cubic feet to cubic inches to cubic centimeters, which is going to be the same as the milliliters, but we'll just put it here. And then once we have the milliliters, we can convert this to liters. So keep this in mind that a cubic centimeter is the same as the milliliter, and that's going to be the transition from a cubic length unit to a regular simple volume unit. Let's now do this. So one thing that is important here is to keep in mind that whenever you're cubing something, you need to cube the number and the unit as well, right? So specifically, this is what it means. First of all, we know that 1 foot is 12 inches. We know that an inch is 2.54 centimeters. So therefore, when I'm going from 1 cubic feet to cubic inches, so first of all, the cubic feet is going to be on the bottom. That needs to be cancelled. First of all, because of this cube, everything that I have here also needs to be cubed, meaning this needs to be cubed and this needs to be cubed in order to use in this equation, right? So the feet is cubed, and then I have the unit in the inches, so 12 inches, and I need to cube these as well, right? So obviously you have 1, that number is not going to change, the cube of 1 is still 1, but the unit is going to be cubed. This you do actually need to cube, right? So 12 is going to be cubed. Now times, at this point I would have gotten rid of this, times now inches to cubic centimeters. So this is what you use, cube everything, the units and the numbers. You can't just do the numbers without the units or the units without the numbers. So here we write down that 1 cubic inch is 2.54 cubic centimeters, and this will allow us to get rid of that. Times, this is just a unit conversion because number wise they're the same. So 1 cubic centimeter is equal to 1 milliliter, and this will allow us to get rid of the cubic centimeters. And finally, you see this is the transition point. Now I have switched from a cube unit to a milliliter. Here I need to write down that 1,000 milliliters is 1 liter. So I can cancel this. And now these are just going to be the numbers. So again, make sure you cube these, and you cube these, and everything as follows. So number everything on the top, divide everything that is on the bottom. So doing all of that, you should eventually get 28.3 liters. Let's continue. A few formulas to calculate the volume of regularly shaped objects. So the simplest is the cube, right? So to find the volume of the cube, you're going to multiply, you're just going to cube the side. If it's a rectangular solid, then the height, the length, and the width, you need to multiply all of that. For a cylinder, we have this formula. So it's pi r squared h. H is going to be the height of the cylinder. And finally, if you have a sphere, that's going to be 4 pi r cubed over 3. So let's do this problem. So a textbook. Okay, so 1 second. So a textbook has these dimensions. So that's the length, the width, and the thickness, right? So these are the parameters, and it wants us to find the volume in cubic centimeters. So you have two ways here. You can either convert these to inches one by one, and then multiply everything together according to the formula, and then you will have the answer in cubic centimeters. Or you can alternatively find the volume by multiplying these two together in cubic inches, and then convert that in one step into cubic centimeters. And so regardless how we go, we need to use this. So we know that an inch is 2.54 centimeters. So if we are now in cubes, then everything here needs to be cubed as well. So we can do it. Let's go the second way. Let's find the volume in cubic inches. So that's going to be 10.25 inches times 8.25 inches times 1.75 inches. And so 3 times inches, and that's going to be 3 times multiplication of the inches, that's going to be cubic inch. So this is equal to 10.25 times 8.25 times 1.75. So we have 147.984 437. So I won't round this off. I'll carry it to the last step and round off everything in the end. So this is cubic inches, and now this needs to be multiplied by this. So a cubic inch is equal to 2.54 centimeters cubed, which means you're gonna first cube this number and multiply by this, and I will allow you to get rid of the cubic inches and get your answer in cubic centimeters. So the cube of this is about 16.5, 16.48. And doing that, you should get 2,430 cubic centimeters. And so 3 significant figures according to. Now here, so we have a baseball, and that's a diameter. What is its volume? So remember, the volume was pi r cubed, right? So 4 pi r cubed divided by 3. And you first need to convert the diameter to the radius. Remember, that's the diameter, and the radius is half of this. So just keep that in mind. So divide the 7.5 by 2, so that'll be 3.75. And because it's not specifying anything about the unit, our final answer can also be in cubic centimeters as well. So 4 pi r cubed, this is the r cubed, divided by 3 times 4 times pi is 3.14, remember? And that should all give you 221 cubic meters. And also let's do some examples about the density. So guys, density is the mass of a unit volume, right? Sometimes, people use these terms exchangeably in saying that something is heavier or lighter, and we're talking about the density because density is in a way a mass, but it needs to be specified in a unit volume. So the formula of this is density is equal to mass divided by volume. Remember that. And usually you can go based off a standard of having grams divided by milliliter. And the reason for this is that because the density of the water is equal to 1 grams per milliliter. That's kind of like a standard. So if we say, for example, that the density of the honey is, I don't know what it is actually, but 1.5, for example, grams per milliliter, then relatively now you can have an idea of say that, oh, that sounds like something very viscous or heavy. That's a lot heavier than the water. And that's just like a reference point. But of course, it does not have to be grams per milliliter. In here, it can be any unit, any mass unit of volume. So let's look at this example. So 45.8 milliliters, and it's 40 grams. You need to find the density. This is a very simple example. You just need to divide these two numbers together and keep the units at the end. So this is 0.83 grams per milliliter. And looking at this, you know that it's a liquid that is lighter than the water. So that's the division. Now, this is a type of a question that you will also be doing in the lab. Sometimes you need to find the volume of an object that doesn't have a regular shape. For example, let's say you take a rock, just a random rock. You can't use a ruler to measure the sides and cube them and get the volume. And that's a irregularly shaped object. So one way of finding the volume of irregularly shaped object is this. Suppose we can take, let's say, we take a cylinder that has the marks of the volume, and we add this object into the cylinder. So let's say the rock or a few of them or metal pellets, whatever that can be. In this case, it says it's a metal sample. So let's say this is our sample. So what is important here is to see the initial volume, right? So let's say initially it was here. it says initially it is 50.7 as an example. And once I added this sample, it went up, right? So it went up here, and this is now 64.4 milliliters. So this is the change of the volume. This is how much liquid has displaced, right? So the difference of these two, 64.4 minus 50.7, that's how much we have, that's how much water we have displaced, right? So that's 13.7 milliliters. And that change of the volume, that displacement, can only come from the amount, from the volume of the object that we're adding here, these metals. And it means that this is actually the volume. And what you need to find, so here it's asking you, you need to find the mass, right? So and you have this formula. Now you need to be able to manipulate this formula, the fraction, and get what you want. So one way to look at it is this: d divided by 1, because d is the same as d divided by 1, is equal to mass divided by volume. So remember, if you need to get the expression for the mass, you first cross multiply. So 1 times mass is equal to density times volume. So 1 is not doing anything. So mass is equal density times volume. Therefore, it's going to be equal to 2.70 grams per. Actually, let me just move it here. So 2.70 grams per milliliter times the volume, which is 13.7 milliliters, and make sure that you're able to cancel the units, right? So this gives you 2.70 times 13.7, so that's 36.99, and I need to keep 3 significant figures, so that's 37.0 grams. So the reason I mentioned that you need to make sure that you can cancel the units is because sometimes students forget how to you work with the fraction, how to do cross multiplication, and maybe mistakenly they get that the mass is equal to, I don't know, volume divided by density, right? So of course this is wrong. This is just an example. But if you do that, then you would have that this is equal to 13.7 milliliters divided by 2.7 grams per milliliter. And this doesn't work because these two together do not cancel. In fact, if it is here, it jumps up and you're getting milliliters squared divided by grams, which that unit makes no sense, right? So you can't have milliliters squared divided by gram. So one thing important here, keep in mind, you always want to make sure that your units work just like as your numbers do. All right, so here's the answer. So 30, the question might be. So here we have a rectangular object. So we have the mass, we have the length, width, and the thickness, and we need to find the density. So it's not going to be just one conversion, right? So first you're going to find the volume, and you have the mass, and you need to divide these two numbers. And at this point, it will be really good if you just pause the video, try to solve this question, and then check how it is done. And so the volume of this is going to be that number. So we have 239.625 cubic centimeters. And we now need to divide these two numbers, and we get that the density is 0.45 grams per cubic centimeter. So this is just a two-step. Now, whenever you work in the lab, there's always going to be a certain percentage error. You can't always get 100% result. Sometimes it's possible, but usually it's very difficult. And it's not a matter of just a student doing it. Even if you are working in a company already, you are an advanced specialist, sometimes that happens. There's an experimental error, percentage error. And so what it is it's the difference of the observed and the actual. So observed is what you got. So in your experiment, let's say you are asked to determine the density of a metal. So you got some number, let's say you got 10, but in reality, you know that it is actually 11, for example. So you divide these two together, you divide the difference of what you've got and what it should be, and times 100, and that's going to be the percent error. So in this case, it's going to be 1 divided, and precision require a better accuracy. Now let's see here. It says that the density of the aluminum is 2.7 grams per cc is cubic centimeters. So that's the same as the milliliter. And it says that it was determined that in the experiment, the student determined that it's actually 2.61 according to this data. So what's the percent error? Again, this is something simple. You need to get the difference of these two and divide by the accepted value. You should never get a negative number, because here these are in brackets, and it just means that it needs to be a positive number. There's no such thing as negative 3%. Now the temperature, so 3 units, right? So we have the Fahrenheit that we're used to, we have the Celsius in the metric system, and we have the Kelvin, which is the SI unit. In certain cases, Kelvin is going to be used. When we get to chapter 5, talking about the gases, or chapter 6 in the thermodynamics, we're going to use the Kelvin. Other than that, you will always be using the Celsius. So Fahrenheit is never used in the laboratory. You will always need to use the Celsius. And this is the formula going from Fahrenheit to Celsius. Or you can also derive a formula from going from Celsius to Fahrenheit. So you can go both ways. Going from Celsius to Kelvin is very straightforward. You just need to add 273. All right, so different systems, different in a normal human body temperature is 36.6 degrees Celsius. So as compared to the 97 Fahrenheit. Now, so let's say here it says that the temperature in Lisbon is 17 degrees Celsius. So what you do is you use this formula in your calculations, and that should give you 63 Fahrenheit. So these questions are actually straightforward, and it says that the normal body temperature is 98.6 Fahrenheit. What is in Celsius? Pause the video for a second, do these conversions, and then check. All right, and so do these conversions based on the significant figures. It's going to give you 37 degrees Celsius, even though it feels bad when you are 37 degrees Celsius. That is actually a fever. So the number is 36.6. Okay, so this is the last type of the conversion, so the temperature. And